said to be down the hole though. What did he say? That story is awful. I would have been scared for my life.
Alright, let's go over suggested problems from yesterday.
Yeah.
And I actually don't have these down up here. So, we're going to have to do this from memory. You guys tell me how I do. I think to make this a little bit easier to see, I'll just circle the ones that are soluble. So anything that's not circled in this first section should be insoluble. That one is. I know that one is. Now I gotta look at my sheet. No, please be quiet. Silver bromide should be solid. Oh, barium hydroxide should be soluble.
The frickin' middle version, that's the worst. The middle version, oh my god.
Lead sulfate.
Anybody but all of them. I don't need a doctor.
I believe those are the ones that should be soluble. So those are the ones that you should have AQ after. Hunter, can you stop? I did. We'll get down to the bottom ones in just a minute. But the top ones, all the ones that are circled, should be soluble, so you should have AQ there. The other ones should be solids. They do not dissolve in water easily. Now, for the bottom ones, I use colors here to make it a little bit easier to look at. And so, anything that is blue should be an AQ. Anything that is red should be a solid. We're looking at 23. I may have made a mistake there. Oh, no, I didn't. Never mind. Rubidium.
The Terminator. We're having a debate. What's the best picture in house? The one above his toilet? Toilet, or the one when you're walking down the stairs by the window?
Okay, any questions on these? No questions. So everybody got all of those right.
If I know which ones are no reaction.
What? My lord.
What happens when they're both solid?
Right here, as long as they're on the product side, this is fine. This one would still be an okay reaction. Because when they mix together, you get two solids. That's okay. In the net ionic equation, it's just you would separate the ions in the equation. Right, 23, this one right here, we would say no reaction.
So if there's a solid on both sides.
Well, the basic thing is if there's a solid on the... So if all of them are AQ, that's no reaction, or if there's a solid on the reactant side, then you would say no reaction. Okay. Any other questions there? Yep. As far as I can see. Everybody feels real comfortable about doing those?
Yeah. I'm real comfortable with the sheet.
Yeah, I mean, it's all right here. It's just being able to read through. And the biggest thing is not missing stuff. Most of the problems come in that, like, for number 3, people see, oh, chloride, bromide, and iodide. Oh, that means this one right here should be soluble. But you got to look for the exceptions. So make sure you read the entire sentence. Look for those exceptions. Okay. Today we're going to do some practicing, and I actually have an experiment to show you, but first we're going to do this one. Not the gummy bear one yet.
Oh! Ouch! The mess one. How to properly make this.
So, at this point, something that we should be able to at least attempt to do is I give you 2 chemicals, so aluminum and hydrochloric acid. You should be able to write a reaction, write the formulas down, predict the products, tell whether or not the reaction will happen, make sure you balance the reaction. So we got aluminum and hydrochloric acid. Put those together, see if there would be a reaction based on what you know. Balance it if you need to. Give you a couple of minutes to look over that one, and then we will go over it. Well, that'll be something.
I don't know for sure though.
Are you settled and organized now?
Why do you have an ancient time? How would you know it?
No, not aluminum acid. No. No. Yep. I know. I could have wrote aluminum metal, but then people go, "What do you mean aluminum metal?" Well, it's aluminum. A chunk of aluminum is thrown into hydrochloric acid. What happens? Anything? Something?
Hold on, I'm still working on it.
I
have no idea.
It's like ancient acid.
Yes, I can.
Do you want to try this at all, Allie?
I think I got it. This down.
Bowen thinks he got it. Do we use chloride?
Perhaps you should come in on a morning so that we can go over some stuff.
Bowen says he thinks he got it. Do we use chloride or chloride? I don't know what I'm doing. Chloride, right?
Yeah. Remember, the hydro tells us that it has to be chloride.
Well, you know, you could just send it.
Then we need to find out which ones are solid.
have the formula, but I don't know. Oh, God.
Chloride. So this one is
Aluminium, what are you?
I don't know. I'm stuck on that. This one has to be aqueous because it's an acid, right? Acids are aqueous.
I'm gonna say
Yeah, acids are always aqueous now.
so.
Hydrogen has to be. Wait, did you want us to draw the write the net one?
Gas. No, you don't need a net ionic equation here.
Where's the big one?
It doesn't really make. I mean, there's a single replacement reaction. It's a single replacement reaction, so a net ionic equation wouldn't even be useful here.
Well, AL's a solid, right? So I can't.
Single replacement. The solubility rules do not matter.
Oh my lord.
Because as we said yesterday, the solubility rules are for double replacement reactions.
Okay. Hold on a second.
So all we need to do is write the thing.
Write the thing.
Okay, I wrote this thing.
I wrote the thing.
All right. All right, so the first step here would be to come up with formulas for the names that we're given. So, aluminum. That's just off the periodic table. Al. Hydrochloric acid. What does the hydro tell us?
Water.
Well, the acid tells us it's an acid. What does the hydro tell us? Right. We use an element off of the periodic table. That's what we're pairing the hydrogen with. So this isn't chlorate or chlorite. It is the chloride ion, just Cl. And since hydrogen is a +1 and Cl is a -1, our formula is HCl. So that should be our formula for hydrochloric acid. Okay? Now, the next thing. Does this look like it's going to be a double replacement or a single replacement reaction? Single, because we have an element here and we have a compound here. That's what tells us it's a single replacement. Now, don't get confused. We could have wrote it the other way. Right? It worked just the same. The point is, we've got one compound, one element. What we need to see is, can this replace one of these things? So the solubility rules here don't matter. Solubility rules are always when you have two compounds that are, we're going to see if one of them is stronger or more soluble than the other one. It comes out on the other side. So here, all we're going to look at is the activity series. So, first step, we've got hydrogen, we've got chlorine. Which one is the aluminum going to try to replace? The hydrogen, because it's a cation and aluminum is a cation. So, we look at our activity series. Can aluminum replace hydrogen in hydrochloric acid? Yes, because this is an acid. It wouldn't be able to do it in water, but in an acid it can. So, this is a reaction that can happen. So, now we have to predict the products. If aluminum ends up with chlorine, the aluminum's charge is +3, and the chlorine's charge is -1. So we need 3 chlorines for every 1 aluminum so that the charge is balanced. Okay? And then we need hydrogen because that's the thing that gets replaced, but hydrogen, of course, is one of our fun diatomics, so it's always got to be H2. And then we have to balance it. Okay? Al's are already balanced. We can balance the chlorine, so we put a 3 right here. Uh-oh. Need a least common multiple. So let it put a 3 right here. We'll go back this and change this to a 6. And then we'll put a 2 right there, and we need a 2 right there. Okay, so this is the reaction between aluminum and hydrochloric acid. It produces, so when you have 2 aluminum atoms, they react with 6 hydrochloric acid molecules to make 2 aluminum chloride molecules and 3 hydrogen gas molecules. And in this case, the hydrogen is a gas, so it will actually bubble out of the solution. And this is the reaction that we are going to look at today.